Hello and welcome back. Yesterday, we started with some basic concepts of chemistry from Unit 1. Today, we will see some more interesting things about atoms and molecules. Now, in your previous classes, you've learned that an atom is the smallest particle of any substance that can take part in chemical reactions and also maintain its identity throughout all physical and chemical changes. And a molecule is the smallest particle of any substance which can exist independently under normal conditions and also exhibit all the properties of the substance. Now, today, let us say what is meant by atomic mass and molecular mass. Atomic mass, it is defined as the average mass of an atom of an element in atomic mass units. And molecular mass, it is defined as the average mass of a molecule of a compound in atomic mass units. Now note that in both these cases we are using average mass. Why are we using average mass? It is because most of the known elements, they occur as a mixture of their various isotopes. Now an isotope or isotopes are atoms of the same element which have the same atomic number but different atomic masses. So if we have hydrogen, hydrogen also has three isotopes. One is protium with mass 1, the other is deuterium with mass 2, and another one with mass 3, which is called as tritium. These are the three isotopes of hydrogen. Now, any given sample of hydrogen may contain all these three isotopes. So which one, the mass of which isotope will be taken as the mass of hydrogen? That creates a problem, isn't it? So the only solution in these cases is to take the average of the masses of all the isotopes. And therefore, in our definition of atomic mass and molecular mass, we use average masses. Now, atomic mass unit, it is expressed as AMU. Nowadays, it has been replaced by unified mass, which is expressed as U. Atomic mass unit or unified mass, this represents the mass that is exactly equal to 1/12 of the mass of a carbon-12 isotope. So one atomic mass unit or one unified mass will be equal to 1/12 of the mass of an atom of carbon-12 isotope. So 1/12 of the mass of carbon-12 isotope, the absolute mass of a carbon-12 isotope, it is 1.99 into 10 to the power minus 23 grams. So if we divide this by 12, we get 1.66 into 10 to the power 24 grams. That means one atomic mass unit, which is equal to one unified mass, will be equal to 1.66 into 10 to the power 24 grams. Now, molecular mass of a substance can be easily calculated by just adding up the atomic masses of all the elements present in a molecule of that compound. So if we have H2O, that is water, if we want to calculate the molecular mass of H2O, we just add up the atomic masses of these two elements, hydrogen and oxygen. Let us try to calculate this. Mass of one hydrogen atom is taken as 1. And there are 2 atoms here, so we multiply this by 2. And mass of one oxygen atom is 16. We add this up, we get 18. This will be the molecular mass of water molecule. This is expressed in unified mass or in atomic mass units. Likewise, if we have H2SO4, sulfuric acid, what will be the molecular mass of this H2SO4? Mass of hydrogen will be 1 into 2 again. Mass of one sulfur atom is 32. Mass of one oxygen atom is 16. There are 4 oxygen atoms here, so we multiply this by 4. 2 plus 32 plus 64. This should give us 98 unified mass, and this will be the molecular mass of sulfuric acid. But for ionic compounds like NaCl, when we write NaCl, so sodium chloride, we represent it by NaCl, but this is not the actual molecular formula of NaCl, because in NaCl we don't have these NaCl molecules. We have sodium ions and we have chloride ions. So this just represents the ratio in which sodium and chloride ions are present in one crystal of NaCl. In a crystal of NaCl, each sodium ion is surrounded by 6 chloride ions. At the same time, each chloride ion is surrounded by 6 sodium ions. So the ratio of sodium to chloride ions is 6:6, or 1:1. And therefore, we write the formula of NaCl like this. But remember that this is not the molecular formula of NaCl. For ionic compounds, we don't use the term molecular formula. We use the term empirical formula or stoichiometric formula. Likewise, if we have calcium chloride, then this means that for each calcium ion, there are 2 chloride ions. This is not the actual molecular formula of calcium chloride. This is just the empirical or stoichiometric formula of calcium chloride. So for this type of compounds, we cannot say molecular mass, and therefore we cannot say molecular formula, and therefore we cannot calculate the molecular mass. Since these are empirical or stoichiometric formulas only, the mass that we calculate is called as the formula mass, not the molecular mass. Now to calculate the formula mass also, we just add up the masses of these ions that are given in the empirical formula. So formula mass of NaCl will be the mass of sodium ion, that is 23, plus the mass of chloride ions, which is 35.5. Here we get 58.5 atomic mass units. So whether it is molecular mass or formula mass, to calculate them, we just add up the masses of all the atoms or ions that are present in one molecule or in one empirical formula of the given compound. Now, once we have calculated the molecular or formula mass of a compound, we can find out the percentage composition of the given compound. Percentage composition is in fact just the mass percentage of each element present in one molecule of the compound. So if we want to calculate the percentage composition of water molecule again, we just need to find out the mass percent of the 2 elements, hydrogen and oxygen, present in this water molecule. So the first step to calculate percentage composition, we find out the molecular mass again. We have calculated the molecular mass of water. We got 18 atomic mass units. Once we have calculated this molecular mass, now we can calculate the mass percentage of each element. So mass percentage of hydrogen in H2O will be equal to mass of hydrogen divided by total mass of the compound, that is water, multiplied by 100. So mass of hydrogen here is 2. Total mass of the compound, that is the molecular mass, will be 18, and then this is multiplied by 100. This will give us the mass percentage of hydrogen. To save time, let me do the calculation with this calculator. 2 into 100 divided by 18 should give us 11.11%. So the mass percentage of water hydrogen in H2O is 11.11%. Then the mass percentage of oxygen will be called the mass of oxygen, which is 16 divided by total mass of the compound, that is the molecular mass of water 18, into 100. So 16 into 100 divided by 18 should give us 88.88%. Now remember that for the sake of simplicity, I've used the mass of hydrogen as 1. But the actual mass of hydrogen atom is 1.008. So if you want to find out the actual mass percentage of water, hydrogen as well as oxygen in water, you take the mass of hydrogen as 1.008. The next topic that I want to discuss with you today is about the mole. The term mole is derived from a Latin word which means a pile or mass of stone that are placed in the sea. Likewise, in chemistry, a mole represents a pile or a mass of atoms, ions, or molecules, or even electrons. A mole is defined as the amount of any substance that contains as many chemical units or particles as there are atoms in 12 grams of carbon-12 isotope. Now, 12 grams of carbon-12 this 12 grams of carbon-12 contains 6.022 into 10 to the power 23 atoms of carbon-12. I hope you are not confused when I say carbon-12 here. Carbon also has 3 isotopes, carbon-12, carbon-13, and carbon-14. In this case, we are using the mass of carbon-12. So, this 12 grams of carbon-12 contains this much number of atoms of carbon-12. In our definition, a mole is defined as the amount of any substance that contains as many chemical units or particles are as present in 12 grams of carbon-12, and this contains this much number of atoms. So a mole represents the quantity of any substance which contains this much number of atoms, ions, or molecules. So if we take 1 mole of hydrogen, 1 mole of hydrogen atom, it will contain 6.022 into 10 to the power 23 atoms of hydrogen. If we take 1 mole of hydrogen molecule, then it will contain 6.022 into 10 to the power 23 molecules of hydrogen. Likewise, if we take 1 mole of H2O, 1 mole of H2O will contain 6.022 into 10 to the power 23 molecules of H2O. Now, using this concept, keeping these ideas in mind, let us try to solve some problems. If we are asked to calculate the number of atoms, suppose in 52 moles of helium, calculate the number of atoms in 52 moles of helium. Now, from what we have just learned, we know that 1 mole of helium will contain 6.022 into 10 to the power 23 atoms of helium. Therefore, if we have 52 moles, will contain 52 into 6.022 into 10 to the power 23 helium atoms. So what do we get here? 52 into 6.022 will give us 313.144 into 10 to the power 23 atoms. This we can write as 3.13 into 10 to the power. The decimal point has moved 2 places to the left, so this becomes power 25. Likewise, if we are asked to calculate the number of atoms in 52 unified mass of helium, the mass of one helium atom is 4 unified mass. So 4 unified mass of helium will be equal to 1 atom, because the atomic mass of helium is 4 unified mass. 4 unified mass of helium will be equivalent to 1 helium atom. So if we have 52 unified mass of helium, we will get 52 divided by 4, that is 13 helium atoms. Then finally, if we are asked to calculate the number of atoms in 52 grams of helium. Now, 1 mole of helium is equal to 4 grams. And this 1 mole will contain 6.022 into 10 to the power 23 atoms of helium. Therefore, if we have 52 grams, 4 grams contains this much. Therefore, 52 grams will contain 52 into 6.022 into 10 to the power 23 divided by 4 atoms of helium. So how much do we get here? 52 into 6.022 divided by 4. We will get 78.286 into 10 to the power 23 atoms. Now if we write this in standard form, this decimal will move 1 place to the left side. We get 7.8286, or we can round it up to 83 into 10 to the power 24, because the decimal has moved 1 place to the left side. So this is how we can calculate the number of atoms if we know the number of moles, if we know the atomic mass, or the number of grams present in a given sample of an element or a compound. That is all for today. Thank you so much.